Here is an overview of the class session. Please see your curriculum for a list of items to prepare prior to this class. These can be found under the Prep Steps heading. K-3 instructors, please note the differences in your curriculum. Please see the timestamps in the description below for relevant walkthroughs. Activity 2, Balloon Balance. For this activity, you'll need the supplies listed on your screen and in your printed curriculum. This activity will be done with groups of 4 students. This activity is linked to a survey question as found in the printed curriculum. The goal of this activity is to learn that air has. Start by asking your students if they think air weighs anything. Then cut the rubber band to make it a string, and tie one end to the center of the dowel and hold the other end of the string. The dowel should be horizontal. Tape an inflated balloon to each end of the dowel and adjust the string if necessary so that the dowel remains horizontal.
It's only in both directions because if it tips the other way.
Let the air out of one balloon by using scissors to cut it at the neck in a way that allows the deflated balloon to stay attached to the dowel. If the dowel spins towards you while the balloon is deflating, push it away from you. Activity 3, Wind Bag. For this activity, you'll need the supplies listed on your screen and in your printed curriculum. The goal of this activity is to investigate how fast-moving air creates an area of low pressure around it, which causes surrounding air to rush in. Ask your students how many breaths it takes to inflate the wind bag. Have 2 students stand at the front of the room and fully extend the wind bag between them. Give the student holding the open end of the bag a straw and have them bunch the opening of the wind bag around the straw. They should now try to inflate the wind bag by blowing through the straw. They will not be able to do this quickly, and you should stop them after a moment to prevent them from getting dizzy.
Just like capture it, don't you? And then close it. Or you have
Oh,
you have to like
okay.
grab it while it's.
Yeah, do that.
Yeah, perfect. Alright.
4. Tornado Tube. For this activity, you'll need the supplies listed on your screen and in your printed curriculum. This activity is linked to a survey question, as found in the printed curriculum. The goal of this activity is to investigate a vortex by creating a model of a tornado. Start by reminding your students of how you spun water in a vial in a previous activity, and remind them that the spinning is called a vortex. Show students the bottles in the tube connector. One of the bottles should be about 2/3 full of water. Ask your students how you can use these materials to make a vortex. Add 3 beads to the water and explain that this is to more easily see the movement of the water. Screw the tube connector onto the full bottle, then screw the empty bottle upside down onto the connector. Make sure the connector is very tightly attached on both ends, otherwise water will leak out. Turn the contraption over so the water is on top. And as you can see, it won't go through yet. With one hand on the tube connector and the other on the lower bottle, swirl the water inside vigorously while keeping it vertical by making a very fast stirring motion. And it's a little vortex. Yeah. Be sure you close the tube connector well, because I didn't, and now it's leaking all over the table. Not ideal. Didn't go all the way through there. Once you've made the vortex, set it down on the table to observe. Start a discussion about what happened and what it looked like. Let the students take turns swirling it. Ask them why the water spins and what would happen if you... Now turn it over so the water is on top and set it down on the table without swirling it. The water should stay mostly in the top bottle. Ask what happened and have your students suggest what you could try to get the water through besides swirling. You can try their ideas and be sure to include turning the contraption to be at a 45-degree angle where it should start glugging through. And the glugging is because the water and the air have to take turns passing through the tube connector, so it's slower. You can also try just squeezing either the top or the bottom bottle. Alright. Ask them which method was the fastest, and the answer will be the vortex because air and water are passing through the tube connector at the same time, so they don't have to take turns. Start by challenging your students to design a wind-resistant building. Give each student a piece of construction paper, a piece of white paper, 2 index cards, 3 silver paper clips, and about a foot of painter's tape. Scissors should be available as students use these materials to build a structure in whatever way they like, besides taping directly to the table. This should be done in a relatively short amount of time to allow for a second round of building later. Get your students thinking about how they would test their structure for wind resistance. Give each student a straw and have them blow through it out their structure. Ask them if their building stayed standing and what would happen in a stronger wind. Fifth time's the charm. Give each student a piece of construction paper and a solid color paper clip. Show them how to fold the paper accordion style with 1-inch folds and clip one end of the paper clip to the end of the paper to make a paper fan. The student should now wave their fan near their building. If time allows, you can have your students do a gallery walk to see each other's designs. Explain that this isn't cheating and that scientists collaborate and use each other's ideas. Now give each student another set of materials with which they can either add to their original design or start from scratch. You can introduce new features in this round, such as students being allowed to trade materials or being allowed to tape directly to the table. Students then test their new or improved buildings using the fans from the first round. Activity 5, Daily Debrief. Activity 5, Daily Debrief, was first presented in Class 1, Activity 5. If you are new to teaching the AKA Science curriculum or would like a refresher, please see the video guide for that class.